model a podium tower structure. So the basic configuration of a podium tower structure is like this. We have the tower and we have the podium, and we connect the podium and the tower together using a transfer plate. Whenever we have a change in the column layout, in order to maintain a continuous load path, we know that we have to incorporate a transfer plate. So this is the podium tower structure, and let's see how to model this using MIDAS Gen. So for demonstration purposes, I will be using this example, where this would be the general arrangement for the tower, and this would be the general arrangement for the podium section. So so let's first define the grid lines. Define the grid lines. So I will say this is the one, and in the x direction we have 2 of 5, 2 of 6, and again 2 of 5. So I would say 2 of 5, and then I'll just go with this. And then I have 22, then I have 27, and then I have so we have 2 of 5, 2 of 6, and 2 of 5, and in the y direction we have 2 of 5.5, and again 2 of 7. So 5.5, and then we have 18, and again we have 25, then we have 30.5, and again we have 36. Okay, 2 of 5, 2 of 7, and 2 of 5.5. Yes, so the grid line is okay. So let's okay, so we have the grid line, and let's pick up the nodes. So to create nodes, you have to go to a node element and create node. And okay, let's first save this. Okay. So let's first okay, so before moving on to anything, let's first define the material properties. So in this example, I will be using grade 30 and grade 40 concrete for so grade 30 concrete mainly for the beams and slabs, and for the transfer plates and the shear walls I will be using grade 40. So let's define these. In MIDAS Gen, you can easily select the Eurocode and give whatever the material property that we want. And again, let's add concrete Eurocode, and I want 40. Okay, so that's done, and then let's go to sections. So in the example, in my podium part, I have 300 by 600 beams and 750 columns, slab of 200 thickness. So let's define those. It's a solid section, 300 by 600. So always remember about the units, be aware of the units. I'm using kilonewtons and meters, so I have to so this is user defined. I'm gonna define, I have to define in meters, so 0.6 by 0.3, and then again for the columns, 750 by 750, user defined, 0.75, 0.75. Okay, and again for the tower structure, we have 230 by 550 beams and 600 by 600 columns. So 230 by 550, user define. It's always easy to start by defining your sections and material properties. So user defined 0.6 by 0.6. Okay, and so in this I will be activating the rigid flow diaphragms, so I do not have to model the slabs. Whatever the dead weight that's coming from the slab will be applied onto the beams, so I do not have to define a section for the slabs, but I have to define the transfer plate and as well as the shear walls. So for the transfer plate, I will give 2 meter thick transfer plate. So 2 meters, and then for the shear walls, I will use 250 millimeter thick shear walls. So 250, I would say. Okay. Let's just make this, so it's gonna, okay, so we're all set. We can start modeling now. So to do that, to draw the beams, let's go to node element and create your element, and in this section you have to choose the material property and the kind of beam type, the beam section that you want, and it's better to use this option, orthogonal, so that your lines will be straight, and you can just draw. Yeah, how convenient. So okay, and let's just not get the 3D view. It's easy to work with the 2D view, so okay, so I have my general arrangement for the podium structure, the podium part of the structure. So the next step would be to model the lift core, the shear core.